We're going to look here at a more general circle. When we have mod z is equal to 3, we know now that that is a circle centered at the origin with a radius of 3. But how do we move to a different center like this circle here? So what we're going to be looking at, as we can see in the diagram, is a circle with a center at a point W, where W is a complex number. So what we have is the set of points Z such that the distance of Z from W is equal to some constant. W is a fixed complex number and K is a real constant. So W is here, K is a constant, so therefore as we go around it's a fixed radius. Z is going to be the set of all of the points that lie on this circumference, because all of those points are going to be a distance K from the complex number W. So it's important to remember this form. Z minus W is equal to K for a circle centered at the complex number W. You'll be expected to draw them and recognize them. We know that in the real number system that x minus a is the distance between x and a. For example, if we had mod x minus 2 is equal to 3, that would be the distance from 2. Therefore, x could be 5. That would be at a distance of 3 from 2. Or it could be at -1. Similarly, for complex numbers, mod z minus w is the distance between z and w. I've mentioned this several times, but it's an important point. Therefore, for z, such that z minus w is equal to k, modulus of z minus w equals k, we are looking for a complex number z that is k units away from w. Hence, we get a circle centered at W. Now, we can find the Cartesian equation of this circle, and sometimes you're required to do that. So Z, of course, is our general complex number, x plus iy. It's a general complex number, but of course it satisfies that constraint, which is why it goes around in a circle like this. W, though, is a fixed complex number, so a plus ib is such that a and b are constants in any given situation. So what we're doing is saying that the modulus of z minus w is equal to k. Well, that's the modulus of x plus iy take away a plus ib being equal to k. So that gives me the modulus of x minus a plus I y minus b, that's collecting up the real and imaginary parts, is equal to k. Well, we know that the modulus of a complex number p plus qi is just the square root of p squared plus q squared. So we have the square root of x minus a squared plus y minus b squared is equal to k. Squaring both sides gives me x minus a squared plus y minus b squared is equal to k squared. And we can see from the Cartesian equation that we have a circle with its center at AB, which of course is the position of the complex number W in the Argon diagram, and the radius is equal to K.